kudos. Kudos to all of us here who make this stuff possible. And I'd especially like to thank our speaker today, Ed WX2R, Ed Efchak. He is the Public Information Officer for the HAMSCI Organization. And I would just love to hear, Ed, before you actually get into the talk, just a little bit about yourself. Tell us about your license, how long you've been licensed, and all the neat stuff that you've done. And we'd love to hear that and get into the HAMSCI Organization. Without further ado, Ed Efchak, WX2R. Thanks. And go ahead. And unmute yourself, Chris.
I got to unmute myself first before we do anything.
Right. Now we hear you. Here we go.
Yeah. So thanks. It's really a pleasure to be here. So and as many of you know, I'm on the other side of the river. I'm the Jersey guy here. So and although tonight I've got true confessions, I'm in West Palm Beach. So because we're spending the winter down here. So if you've had a rough couple of days, my empathy to you. So in terms of a little bit of background, let's see if I can bring this up. So it looks as though I'm not being able to move the screen, Gary. So
use your left or right arrows.
yeah, I'm using my down arrow, but it's not really working here.
Use the right arrow.
Pardon?
The right arrow.
Right arrow, right. That's still not working.
And click once with your mouse. Click. There you go. Click and then use the right.
Ah, there we go. There we go. Thanks. So anyway, a little bit about me. I'm WX2R. I've been licensed since 1976, so I've been around a while. I started as WN2AIV and then KB2IKI. I'm not a physicist. So for Lou and others who attended Saturday's presentation at HRU, this is going to be a different presentation. If you need Nathaniel's deck, I'll be glad to send that on to you because this is a little bit different. Again, he's the physicist. I'm the marketing guy. I worked for many years in strategy planning and media, market research and marketing. If anybody knows the Bergen Record, in Hackensack on the other side of the river, I worked 35 years there in the newspaper and the television business. I'm a pretty basic ham. I've got a small station. I do casual operating. I'm an association guy, as you can probably tell, with ARL and everything else. I believe in groups and I believe in clubs. And I'm just listening. I belong to the Fairlawn Club and a lot of the same issues that you guys were talking about in terms of attendance or things that we have, over on the other side. I was the PIO for many years for Northern New Jersey, going back to Rich Mendelson and those guys. Now I'm the PIC for the section here for ARL Northern New Jersey. I'm on the ARL PR committee, which is a group of about 7 or 8 people that report into Newington. I belong to the Fairlawn Club, FRC. I'm a contester, casual contester. Club in Vermont when we lived up there, West Palm Beach, because we spend time down here. And also a member of the Chelmsford Club in the UK, which was a club formed by Marconi, interestingly enough. So, and I'm now the Public Information Officer for HAMSCI. It's one of the cases where you see a need and you raise your hand and you get the job. And so between now and really into next April and then a little bit beyond, I'm the PIC or PIO for the club, for the group. And obviously to be that, you've got to be a strong believer in citizen science. And we'll talk a little bit about that towards the end of the presentation. So if anyone doesn't know about ham radio, about HAMSCI, it's the Ham Radio Science Citizen Investigation. It was founded back in 2015 by the gentleman on the bottom left-hand corner of your screen, Dr. Nathaniel Frizzell, W2NAF, who was the speaker on Saturday at Ham Radio University. He's been a real strong believer in terms of putting scientists, primarily physicists, and people who are involved in terms of the mathematics of ionospheric science together with ham radio operators to really begin to do a more collective scientific investigation in terms of what's going on in the ionosphere and obviously bring people together. So the objectives are rather simple. It's to advance scientific research and really using ham radio activities to encourage the development of new technologies to support research in ionospheric science and provide educational opportunities. Not only for the amateur radio community, but also for the general public as well. So, and we're a growing group of volunteers. And we'll share a screen at the end in terms of if you want to get involved in some of the meetings that we do, which are, transparent and really open source in terms of just, what HAMSCI is about. But we're here tonight to talk about solar eclipses and why the interest, okay? Obviously, since the beginning of time, humankind has always been fascinated by eclipses. There's been fear and ignorance that led many interesting theories about, why eclipses came about. Astrologers were hired in the early days to sort of predict them. And when they worked, astrologers had a pretty good business. But when they didn't work, okay, those people who were in charge sort of put the astrologers out to sort of execution. So it was a high risk business until the science sort of got better. And astrologers today, I don't know what it's like on Long Island, but you see a lot of them on Route 17 and Route 46. Okay, so while they're not doing predictions for eclipses anymore, is that they are doing, I guess, some predictions regarding the future. So, but the ancient Chinese thought a long time ago that a dragon, it was eating the sun during an eclipse. They would beat drums and pans to scare the dragons away. And actually, having done enough of these presentations, I think that there are probably still a lot of people who believed that that's what was happening, but it's not. Okay, there was a common theme among the ancients who felt that groups of animals, including wolves, chased the sun and the moon across the sky, and the animals would occasionally catch and eat the sun or the moon, making them disappear until they very quickly regenerated. And that was thousands of years ago. So, and then, many years, centuries ago, again, astrologers were tasked by emperors to predict eclipses. If they missed, they could be executed. In modern times, eclipse predictions are highly accurate. No one's life is at risk. And accurate predictions allow us to plan studies of eclipse-related phenomena years in advance. One particular point, and I want to say it early, so in case I miss it, okay, I'll regret that I didn't, is that the eclipse which is coming up on April the 8th, as well as the last eclipse, the annular eclipse, which took place back on October 14th, are the last two eclipses in North America for the next 16 years, almost 20 years. So we always talk in terms of solar cycles, in terms of looking at eclipse cycles, solar eclipse cycles. This is probably the last for a lot of us. But obviously, in terms of just looking at the science in North America, where most of the eclipse work has been done in terms of looking at ionospheric research, this is really the last big chance for about 20 years, and why I think it's important as HAMS that we really help out in terms of some of the investigation that's going to be happening again on April the 8th. So again, two solar eclipses. The annular took place on October 14th. This is basically, we'll do a little bit of the simple astronomy behind it. That's the appearance of the moon and the sun during an annual eclipse. Okay, the sun slightly circumvents the moon. Okay, you see the solar ring around the moon. A total eclipse, however, the moon totally covers the solar disk, and you see some of the things that you never see at any other time, such as the corona of the sun and things such as solar prominences. So, and obviously this is the same type of effect in terms of looking at what we're going to be studying in terms of HAMSCI and some of the experiments, some of the things which can only be uniquely done with a total solar eclipse, and a lot of the work which we're actually learning really for the first time in terms of looking at differences in looking at the ionosphere between an annular eclipse and a full total solar eclipse. So again, basically my premise here is to ask for the order, and hopefully you'll participate with us on April the 8th. In terms of just looking at the basic, sort of the schematic in terms of, how an eclipse works, is that the moon casts a shadow. The umbra is the innermost region of the sun. The sun is fully hidden and the objects are in total darkness. The penumbra, okay, which is the annular eclipse, is that the outermost region of the sun still shows. The sun is partially hidden and objects on Earth receive some sunlight. And at the same time, keep that in mind too, is that there are some propagation changes that are different between obviously daylight and then the occurrences in terms of what happens with an annular eclipse, partial, okay, in the sense of not total solar eclipse, as opposed to a total solar eclipse. So, and obviously here, the distance between the moon varies. And this is obviously the difference between the annular eclipse in 2023, and then secondly, when the moon is at perigee, at closest to the Earth, it will totally cover the solar disk during eclipse, which is the upcoming total solar eclipse on April the 8th. So if I can, just for a second, just so I can get myself out of the way here. HAMSCI is beginning to report observations from the 2023 eclipse. We'll share a couple of those observations towards the end of this presentation. And obviously, hams and shortwave enthusiasts are encouraged to join us in 2024. And this is, when you look here at this map, this is, the two totally different paths of the two solar eclipses over the last 6 months. The annular eclipse starting in the Pacific Northwest and traveling southwest and ending out over the ocean over Africa late in the day on October the 14th. The total solar eclipse, which we'll see in a second in terms of its simulation, starts at sunrise over the Yucatan in Mexico to the southwest and then travels northeast across basically the central U.S., over Cleveland, over Toledo, over Dayton, over Buffalo, over Burlington, just south of Toronto, and then into Maine before it exits at sunset over the Canadian Maritimes. And we'll see a little bit of a simulation regarding how those two eclipses occurred. And HAMSCI is studying really and looking at the effects of what happens in the ionosphere during the period of the eclipse. And it's all about, obviously, the ionosphere. Again, just basically from your novice course or your introductory course in terms of your tech license, is that obviously there are different layers in the ionosphere and they change by night and day. And what we're looking at here is obviously looking at the change from daylight when they're, just in terms of normal daylight propagation and the effects of increasing darkness by the occurrence of the lunar shadow over the Earth, which we'll see in just a second in terms of the simulation, which is a little bit different, than people who are going to be looking at the eclipse from a purely astronomical viewpoint, in terms of looking through telescopes, traditional telescopes, or more specifically, solar telescopes. What HAMSCI is interested in is looking at changes in the various layers in the atmosphere. Starting with the D layer at roughly 80 kilometers, about 48 miles, all the way up to the F2 layer, about roughly 180 miles, 300 kilometers, in terms of looking at some of those changes and obviously looking at the effects of the F1, F2 layers, just as darkness settles in during the brief period by which the eclipse occurs. So in terms of looking at sort of the ionospheric effects and what we might be able to see from a purely visual as well as from an from a radio standpoint, in terms of looking at the radio spectrum, is that after sunrise occurs, but before an eclipse passes overhead, we clearly have daylight conditions. Nothing really changes, no matter where you are in terms of looking at the path of the eclipse. But if you're in the path, of the total solar eclipse or the annular eclipse, is that as it passes overhead, solar radiation is blocked from reaching the ionosphere, which is briefly simulating night conditions. I don't know if, how many of us were sort of present back in 2017, where there was a partial eclipse here in New York and northern New Jersey. We participated, as I suspect you did as well, in the solar eclipse QSO party back in 2017. But from a visual standpoint, it was a really nice day in August, and you could actually see the effects of night, even though it wasn't total, for example, here in Bergen County. But nevertheless, I mean, you could see the effects of darkness, occurring, and it looked dramatically different, from just looking at daylight conditions. And so, I mean, that's basically that piece. And we expect that the ionosphere's reaction will be similar to its reaction to a normal 24-hour day-night cycle. As night approaches, the band begins to change. As we all know, whether it's from whether it's on 20 meters or 40 meters or 80 meters, is that there are band differences in moving from day to night. But there are some differences, and that the eclipse night is much shorter in duration than the normal nighttime. It lasts just a few minutes in most cases. The nighttime area is highly localized. And going back to thinking about the map, is that the width of the totality is probably no more than 30 miles at best in any one particular location. So if you're on either side of it, you're not necessarily going to see the full effect, but nighttime does look different. Don't regard it as you move further away from the path of totality, and it's caused by an object called the moon, which is traveling at supersonic speeds, as opposed to just the fact that the sun is setting. And so there's a different effect in terms of having night being created by a different object than it is by the normal daylight cycle. And it travels in directions that are different from the traditional westward motion of, normal daylight to dawn. As we can see, in the earlier slide, is that the annular eclipse started in the Pacific Northwest, and moved south and moved southeast. Where on the other side of the coin is that the total solar eclipse on April the 8th starts in the southwest and moves northeast. Totally different than what we normally expect in terms of normal daylight nighttime conditions. So eclipses are really controlled experiments. Aside from dawn, dusk, and the seasons, there are very, very few cases where we know ahead of time about how much solar energy will be input into the solar atmosphere. Things such as flares, geomagnetic storms, other space events. Certainly there's been a lot in the last couple of weeks, and they interfere with day-to-day observations of the ionosphere, but we don't know about them in advance, okay? We may have some inclination in terms of looking at the sun and studying it now regarding some of the changes that we might expect to occur, but they're not as predictable as knowing, the effects of the Earth-Moon relationship between each other and when there'll be eclipses and how we might be able to study them. So we can, however, calculate eclipses with great accuracy, and they can be considered controlled ionospheric experiments. And obviously what we're looking for here is that you as a ham can participate in the experiments, which we're calling the HAMSCI Festivals of Eclipse Ionospheric Science, going back in terms of the original definition of what HAMSCI is all about. So this is a quick look at what sort of the modeling has been put together by the HAMSCI physicists in terms of what we might expect on April 8th. Again, we're looking at, sort of looking at the path at about 1500 universal time at a height of about 300 kilometers or about 180 miles. And so again, start to look in the southwest corner of your screen. If I can bring this up, where did my mouse go? Here we go. So, and just let's take a look. Obviously, you see the effect in terms of looking at daylight and night, but there's the sun and the moon in terms of the eclipse, okay, as it moves across North America and then disappears, okay, as nighttime occurs. Let's take another look at it again, okay? Again, and I'll try to, if I can see if I can stop it here, okay? This is a really good chance to look at the effect, and something that we saw in terms of looking at the modeling for the October 24th event was that if you look in terms of what we think the ionospheric shadow is going to be, again, this is a height of about 180 miles, and obviously in terms of looking at a specific time. But I mean, what you see here is that the ionospheric shadow is far larger than what the sort of astronomical shadow is in terms of looking at totality, where the effects of the total eclipse for people looking through telescopes on the ground is rather narrow. That path of totality is rather small. But here, the effects of the ionosphere, of the eclipse on the ionosphere, are rather wide and actually, encompasses a good part of the U.S. If I just, in terms of looking at the stop part here, where the eclipse is centered basically over Southwest Texas, I guess. But the effects can be seen pretty much from early Eastern North America, for lack of an argument, pretty much down to the Pacific coast, which is just a little past sunrise, for them overall. And if we continue the path, again, you see sort of how the exit and how the shadow moves out. One last time, just so that we get a sense of the full effect of it. And if I stop it here as well, I mean, this again looks rather similar in terms of what we saw in October, in terms of the effect. We expect it to be more pronounced because it's a total eclipse as opposed to an annular eclipse. But we had a number of questions in some of the earlier decks in doing this presentation, where a number of people say, well, I'm not along the line of totality, or I'm not even near it. Why do I need to participate as a ham? In terms of looking at, participating in the solar eclipse QSO party or some of the other experiments. Just looking at this slide, this is probably the best example that I can say as a casual ham in terms of why you need to participate, in terms of looking at just the overall size of the ionospheric shadow, for lack of a better word, in terms of looking at its footprint in North America. So that basically where you are in North America, no matter where you are, we'd like you to participate because your signals travel not only through the ionosphere to points unknown, for lack of a better term, but they also cross over the eclipse path, which is what we're looking to do and achieve in terms of understanding some of the measurements that we're trying to achieve in terms of some of the different experiments, which we'll talk about in a second. So why your participation is important, why do I need to be on the air, on April the 8th? This is probably the best reason that I can give you. Okay, overall. So, and again, questions, and I don't want to forget this as well, too, is that if you plan to participate, whether as a club or whether as an individual, is that the ideally, we would like to have you on the entire period of daylight in your particular area. Okay, so we get a sense of understanding some of the things that happen. But if you can be on, primarily 90 minutes before sort of the closest line of where totality occurs for you, which is obviously like upstate New York. In terms of also about an hour and a half afterwards. That would be the ideal situation for us in terms of capturing your data, in terms of some of the skimmers that we'll be using, whether it's PSK Reporter, Reverse Beacon Network, some of those others going forward. So that's a little bit about the background here. So let me just take this through. Okay. And hopefully I can exit. Okay, great. So, just in terms of looking at some of the events that we've got coming up for the April event, there's the Solar Eclipse QSO party, which we'll talk about in a second. The Gladstone Signal Spotting Challenge, the GSSC. And again, I'm trying to remember all the things that we have going on. If you're interested in some of the results of the GSSC, okay, in terms of looking at Whisper, they have been published, on the HAMSCI site, and we've got a release that's going out, I believe tomorrow, on that, and just in terms of bringing you up to speed, and then some of the other things that we're doing is the opportunity to build and install a great personal space weather station at PSWS, which we'll talk about in a second. We're working on a ionospheric layer height experiment, which we'll share in a second, the time delay of arrival event. If you're an AM SWL, which like a lot of us, how you got started in the radio hobby, is that there is a medium wave band recording experiment going on, which if you'd like to participate, we'd love to get your logs in terms of recordings, in terms of focusing on a station and tracking its signal as the eclipse approaches you and then goes past you. And then if you're a very low frequency enthusiast, okay, is to monitor 630, the 630, 2200 meter and lower bands in terms of looking at some of the effects that may be going on the VLF bands, which has been an area that has been relatively unknown in terms of looking at ionospheric science. So let's take a look at the biggest part, the single part of the number of experiments that are going on, and that's the Solar Eclipse QSO party. Okay. What this is basically just the fact that it's a get on the air event. It's a QSO party that involves hundreds of hams operating on the HF bands between 6 and 160 meters simultaneously. Okay, resulting in thousands of QSOs and spots per hour. The only, I guess the only caveat here, as I'm thinking about one presentation to another, is that we're not using the work bands. Okay, so it's primarily the main bands that we would use for operating on. Basically, if for the October 14th event, or back in October, is that was also the day of the Pennsylvania QSO party, and I believe it was the California or Arizona QSO party that day. Philip Gladstone, who is the originator of PSK Reporter, reported that it was the single between those two contests, other contests that were going on, and the participation in the QSO party, is that it resulted in the highest number of spots ever recorded by PSK Reporter. And he estimated, I guess at its peak, okay, in terms of looking at sort of midday Eastern time, is that there were roughly 8,200 spots per second being reported by hams, through PSK Reporter software. And obviously there was also data that was being collected on Reverse Beacon Network and et cetera. So again, here, I think the key is to get on the air, whether you're participating, just, as a casual ham that day, or whether you're serious about participating in the QSO party, because there is a contest around it, is that we'd love to have you on the air during that day, primarily, obviously, as most of the daylight day as possible, but, certainly around the 3 hours around the peak period regarding totality in your area. The QSO party is basically ham radio's version of a cocktail party. It's really a big room, potentially the entire Earth. We had reports from just every continent, including Antarctica, for the annular event, and certainly would love to get as much response. Although this time it's a Monday for the April event. Can't change the moon; it's a Monday, as opposed to the October event, which was a Saturday. Also, CW sideband and FT4, FT8 QSOs are welcome. Obviously, we're going to capture them as, through as many skimmers, as possible. We're certainly using just about every type of contesting software, whether it's N1MM or what's it F2 JP. We'll certainly support the SEQP party as long as you've got a digital log or if you've got an analog log that you want to sit it in, and we will take care of it and report it. And then the data and spot data, log and spot data will be obviously for scientific research. The past results on the 2017 eclipse can be found at HAMSCI.org. Just search on the 2017 eclipse, and obviously we'll be looking to put up the data not only from the annular but also from the total ASAP once we're completed, particularly for contest reasons. If you're participating in the QSO party in terms of its contest and rules, again, it's 160, 6 to 160 non-work, CWSSB digital modes like FT8. The HAMSCI website is the place to go. Contest info, SEQP for FAQs, or SEQP for the rules. Okay, there are certificates for everyone who plays, and the results will be published, as I mentioned, for the Gladstone portion of it, which is the whisper portion. The results are going to be published primarily in the next 24 hours. So anyway, and obviously this is just a quick look of the HAMSCI page in terms of things to look for when you look for the QSO party rules for 2023 and 2024. Again, annular and total. In terms of the Gladstone Signal Spotting Challenge, for those who are really interested and who want to transmit and receive whisper signals, weak signal propagation reporter, and also increasingly on FST4W. One of the things that we've learned is that the FST4W logs are similar, but they provide a great deal of better performance than just straight whisper. So if you've got the opportunity to participate by using FST4W, please do so. And we'll be grateful, for every data that we can possibly get. The equipment needs are very simple. If you look at my shack, racks of gear are definitely not required. This isn't my shack, but this is a simple Raspberry Pi with a whisper transmitter. Okay, and working with Tapper. Tapper's a partner with us as well. If you're a Tapper person. So the Gladstone Signal Spotting Challenge should appeal to anyone who's already interested in radio propagation. You can learn more from Whisper.live or Whisper Demon, who are partners with us in terms of looking at the SEQP and just in terms of looking at the overall project in terms of experiments. Again, if you're interested in participating in the contest portion of Whisper through the Gladstone Signal Spotting Challenge, again, go to hamsci.org regarding contest info, GSSC FAQs, or GSSC for rules. And the entire 23 results have been published on HAMSCI, and that's I think I'm jumping the gun because this is the results for the October piece, and it's due out tomorrow. So I think I might have jumped the gun with this slide, but you guys are the first to know first. So anyway, and this is a little bit just in terms of if you're going to go to the HAMSCI page on hamsci.org, that's your sort of landmark in terms of sort of catching up on the rules and regs, and hopefully you'll participate as well too. The Great Personal Weather Station is something that's new for this particular for the eclipse. Is that we're placing low-cost SDRs in locations all across North America. For the October annular eclipse, we had 28 grapes placed across North America. These are recording changes in the Earth's ionosphere through measurements of Doppler frequency shifts. And what we're doing is measuring very, very carefully WWV, WWVH, and CHU, obviously the time signal stations. We're looking at just minute variations, in terms of looking at signal strengths and looking at Doppler shifts as the eclipse passes over, so we can actually begin to understand a little bit better at different layers of the ionosphere as to how those signals are attenuated as the moon's shadow passes over the Earth. So in terms, again, a little bit more in terms of GRAPE, obviously, a full explanation of the science behind this is, I always say beyond my pay grade, but it's obviously beyond the scope of this presentation. But in simplest terms, the sun greatly affects the ionosphere. Okay, we can sense, and we can sense the bottom side, so the lower levels, going back in terms of looking at the D layer stuff of the ionosphere by measuring received frequencies of stations such as WWV to millihertz precision. And that's what we're looking to do. If you're interested in building a GRAPE and participating, please send me a note, okay? Public information at hamsci.org, or just go to the HAMSCI site and say, I'm interested in GRAPE. Okay, and we'll get you someone who can help you acquire a GRAPE station. Yeah, it has to be assembled. Okay, but from there to put it together and get it on the air. I'll also mention too, in terms of whisper stations, to go back to Gladstone and the whisper experiments, is that if you have a whisper station and you have not put it on the air for the eclipse, okay, we would greatly appreciate if you would do so. And obviously, we're measuring data 24 hours a day, whether it's eclipse related or not. So if you want to be part of the HAMSCI program in terms of looking at whisper monitoring, get your station on the air and obviously drop a note to hamsci.org. And in terms of follow-up, in terms of get you on the inventory list, in terms of the number of stations. The time delay of arrival event is another one of the experiments that's going on with the solar eclipse on April the 8th. Again, this is again for a science-minded amateur who'd like to be part of a controlled experiment. Is that basically what we're looking at here is transmitting and receiving a chirp signal. And if you've never heard a chirp signal, go on the web, and sort of download chirp signal ham radio to hear what they sound like. They're rather distinctive and unique if you never really work with them, which is custom generated for your station, your call sign. For use during the eclipses, and we're going to be looking at measuring in changes in the F2 layer heights as the solar eclipse impacts the ionosphere. And obviously those are distances between 220 kilometers in nighttime and 300 kilometers at night. For all the details in terms of looking at the time delay of arrival, including a sign-up form if you'd like to participate, is take a look at TDOA event 2023 on the HAMSCI site. We'll talk a little bit about some of the early observations in just a second. So in summary, we're looking at HAMSCI, okay, in terms of the festival of experiments for eclipse ionospheric science. It's fun. It should be a fun day in terms of getting on the air, particularly if you can do it in a public place or with a club or somebody else, because you get a lot of interest. For people like, what are you doing? And you talk about eclipses and people get interested right away. Okay, but it's obviously with a purpose. It's just not another contest. It's not another day on the air. What's in it for hams? Okay, I mean, the long-term benefits of participation are, helping us all collectively understand a little bit more about what HF propagation is all about. This is a unique chance in terms of a controlled experiment to understand, sort of how the ionosphere works, which 100 years ago, okay, which just in closing, we basically knew nothing about it. Okay, why does fading occur in the ionosphere was a question that sort of baffled early radio amateurs 100 years ago, and which we know a lot more about now. But we also want to improve our models of the ionosphere, and which obviously can help in terms of making more accurate propagation forecasts. And going back to looking at some of the things that we talked about a little bit earlier about solar flares, and things like that, in terms of understanding some of the effects and how they might change and better help us better understand, sort of how we can improve our knowledge, of the ionospheric atmosphere as opposed to the weather atmosphere. So, so now's a good time to ask, though, what did we learn from the October eclipse? We've been asked quite often. In fact, every meeting that I did with clubs since really October is, what did you learn from the eclipse? Well, to be perfectly honest, it's too early to make any conclusions, okay? Good science takes time, and it's a slow process. It's important to understand the difference between observations and findings, what we saw as opposed to why we saw it, okay? It's also important to understand the peer review process, whereby scientists review one another's work, looking at things such as originality, accuracy, and repeatability. Can you repeat the experiment? And there's a lot of back and forth that goes on between theories and explanations before really the findings sort of show the light of day. And so in terms of looking at data analysis, is that we're developing and testing theories over time. The data set that we have just from October is huge. Okay, and looking at PSK Reporter and Reverse Beacon Network, is both Gladstone and others have given us as much memory space to capture all the data that we captured on October 14th, and are expecting to do that again, for the April 8th experiment. So, obviously, when you just look at the size of the data set, your QSOs versus everybody else's that are participating, thousands of other hams, hopefully. is that, that data set takes a long time to analyze. And also you're looking to say, what do we really want to learn? Okay, because sometimes, there's serendipity that should come out of science, going forward. And, in terms of the preparation of articles and papers involved in the peer review process, as you know, sometimes that can be lengthy, okay, and possibly years. But we do expect to have some findings in late 2024, this year, 2025 and beyond. In terms of looking at some of the specific observations regarding some of the specific experiments, the great receiver observation, here's evidence that the ionosphere's eclipse reaction is similar to its dawn reaction. What happened as the shadow passed over, in this particular case, Scranton, Pennsylvania, Nathaniel Frizzell's station, W2NAF, is important for validating the receive system. What can be said here is that we do feel pretty good about the early observations. This is a look, obviously, looking at the bottom axis, it's time in UTC. Here was dawn, okay, when you see the dawn piece, that dawn block, in terms of looking at Scranton. And then obviously during the eclipse period, which occurred really between, I guess, like 1200, 1230 hours and roughly 1800 hours UTC, okay, is that we feel pretty good about the early observations. Here that we see that the grape receiving system shows similarities between the dawn and eclipse reactions of the atmosphere, particularly when you look and just sort of looking at that bump in the eclipse piece, as we see what happened between dawn and the eclipse, very, very similar. This is a graph. It's a graph that shows Doppler shift, which is a method to measure and monitor how high the bottom side of the atmosphere is above the Earth. So there's some initial proof in terms of looking at some of the things that are going on in terms of normal daylight observations and what the moon is creating as its shadow passes over the Earth. In terms of looking at medium wave reception operations, this is a graph that is a sense that shows the value of control data, looking at signals day prior to the eclipse versus the enhancement during the eclipse event. Not all observations involve handbands, okay, and not even transmitting. These are graphs of signal strength from monitoring AM broadcast station KKXA in Snohomish, Washington. On the control day, which is October 13th on the left, you can see how the signal steadily weakened after sunrise, moving left to right. Okay, the graph looks much different on eclipse day, again, on the right, moving from left to right. The signals grew in strength as the eclipse passed over the western U.S., a brief period of darkness which caused the signals to dramatically peak. I'd also point you to the HAMSCI website to go back to 2017 to take a look at the experiments that were done with KSL in Salt Lake City, which showed a rather also a very similar effect, although not as necessarily as dramatic as KKXA's are, in looking at the annular eclipse. But nevertheless, the effects were very, very similar. This first, obviously, the KSL experiments were the first time that it had been done in an eclipse setting. One of our scientists, Nick Hall-Patch, VE7DXR, is leading the charge on the medium wave reception observations. And if you're interested, okay, in just if you've got going back to your days of being a good AMDXer, this is a chance to sort of get your signals back out, okay, and send in some recordings of signals, regardless of where you are, okay. And we'll be looking at a couple of control stations, which you should be able to hear as darkness occurs. So drop us a note at hamsci.org, and we can get you involved in terms of being a participant and looking at the medium wave reception portion. Again, which, just like the SEQP, is probably the easiest entry point for many of us as casual hams to participate. So in terms of looking at noise and signal enhancements, again, this is using the careful graphing of received signals using FST4W, was showing the levels peaking on the left and signal levels peaking on the right during the eclipse. SFT4W is known as a propagation study mode, which it did for these experiments rather well. On the right, note the bump, okay, in signal strength at the time of the eclipse, okay, which is the black line at the bottom. You notice the jump in terms of looking at signal strength, okay. And, which for the transmission area between, and this was between two stations in the 7 call area, okay, KA7 OEI/1 and WO7I, okay, on 3.57 megahertz. The left graph shows the received noise levels for 2 receiving stations on California's west coast. okay, for KFS and KPH, okay, in Point Rice, okay. Again, here looking at, the black bars at the bottom indicate the period of totality, or basically, during the eclipse period. And here, obviously, as the moon passed over, you can see the difference in the noise levels, okay, just in terms of recording those particularly two stations. So we've got two different examples across two different types of receiving, whether it's, sort of a government station such as KPH, or whether it's an amateur station such as WO7I, in terms of looking at some of the changes that are occurring here. So, and obviously here, is just, and whether we're looking at any mode, okay, but particularly, but the SEQP, and also perhaps the medium wave event, is that participation is the key. Is the more of us who participate, on April 8th for the eclipse day, the better it is for all of us in terms of science. So if you're interested in participating, I would say follow hamsci.org/eclipse, or join our group, okay, in terms of look at Google groups at hamsci/eclipse. You can pre-register for the events at hamsci.org/eclipse. Certainly operate in the SEQP or the Gladstone Signal Strength Challenge. Join the time delay of arrival event if you can. Put your medium wave or very low frequency monitoring skills to work. And hopefully also too, as well, if you can build a great receiver, okay, and get more, I think we're looking at having close to 50, I think between 50 and 60, on for April going forward, as opposed to the 28 that we had on board for the annular eclipse. But and also in terms of getting involved, we're an open source, fully transparent group. There's 3 opportunities if you're around to participate, and that's Mondays at 9 p.m. Eastern, Tuesdays at 0200 Zulu, which is the engineering telecon to support our SDRs, our tangerines, and our magnetometer board development. Thursdays at 10 a.m. Eastern time is the telecom to support engineering and science related to the GRAPE personal weather station. And our general meeting in terms of what's happening in the group, whether it's on the marketing side or on the science side, are every Thursday at 4 p.m. Eastern time. And that's the telecom to support the 23 and 24 solar eclipse QSO parties. Just drop a note to hamsci.org. When you get on the homepage, you can see how you can join the group. Say that you'd like to participate in the meeting, and we'll send you a link, because the more the merrier. And obviously, we've been absolutely thrilled by the number of volunteers who have shown up week after week, who have lent us support, technical expertise, marketing expertise, and just get out the word in terms of what we need to do to achieve to get a really successful event done for HAMSCI. Also, if you've got time and you really want to see in a sense what's going on inside of ionospheric science, is March 22nd and 23rd. At Case Western University in Cleveland will be the next HAMSCI conference. The theme will be alignments, not only between in terms of obviously looking between the sun, moon, and earth, in terms of looking at the effects of the eclipse, but also looking at the alignment between amateur radio recreation and the STEM curriculum, how we can build that more in terms of the educational, alignment in terms of schools, just educational activities, better alignment between data collection and analysis, and obviously a better cooperation and alignment between professionals, primarily physicists, and citizen scientists such as ourselves as HAMS. So join us in person or online, join our mailing list, and you'll learn a lot more about it, particularly as we get closer for hamsci.org/2024. So I think that's about it, but I'd like to close just with a little bit about citizen science. And I tend to think that, we sort of forget the background regarding a lot of things how things started, and also a lot of, sort of how things come around, even from the standpoint of 100 years ago. At our last, and I lost it here, but okay. But at our last HAMSCI conference in Scranton back in March, there was a presentation by Nick Volpatch, VE7DXR, in terms of looking at medium wave de-Xing and the eclipses, which he did a passing reference to this particular page, which appeared in Scientific American back in April of 1925. 1925, just about 100 years ago, which was the eclipse, or the effects of the eclipse on radio. And this was a solar eclipse that took place remarkably over Long Island, over North Jersey. And you could see where it started back, I guess, up in the upper, over by Lake Superior, out that way. But what Scientific American did 100 years ago was rather unique in terms of citizen science, is that it asked its readers, okay, if they would take their fledgling radios. Now, what did a radio look like 100 years ago? Crystal sets, those types of things. And listen to a station and tell them what they heard okay, in terms of what happened when an eclipse passed over their particular location. And this was their report, okay, which goes on about 6 or 7 pages. And it was really quite remarkable. In fact, that A, it was 100 years ago. B, that a group such as Scientific American would take it on. You know, in looking back over 100 years, you know, a lot of the research was rudimentary. You know, a lot, you know, I guess, and a lot of the physicists that I've spoken to regarding this, because when I heard it, I said, we've got to partner with Scientific American to see if they can replicate for this. Yeah, but their response was is that, you know, the research wasn't that good because it was rather, you know, rather, I guess, not slipshod, but it was rather not necessarily unprofessional in terms of how it was structured and put together. But nevertheless, a lot of the early points, okay, that came out of what we're learning today in terms of ionospheric science came out of this, you know, sort of this basic report back in 1924. Interestingly enough, we've just, you know, if you read Scientific American or get their emails, we were featured about a week or two ago for HAMSCI, which I thought was a nice 100 years it came around. Yeah, and we certainly were featured for a story that, quite honestly, in terms of looking at citizen science and getting their readers to participate in science, they were the lead about 100 years ago. I'll also point out that, you know, I guess in going back to the ARL, in the early days of the ARL, in terms of understanding with the National Bureau of Standards, understanding, I mentioned things such as fading. How did you understand, you know, how did we begin to understand why fading occurs in the ionosphere if you're listening to radio signals? That was you know, there was nothing much was known about that until 1925. Okay, where the league partnered with the National Bureau of Standards to get HAMS to be the citizen scientists, okay, to be able to capture data and, you know, I guess, you know, the original logging, you know, in terms of SINPO reports and things like that came out of those, you know, came out of that scientific project over 100 years ago. So citizen science is coming full circle, and that's what we're asking here, you know, in terms of looking at HAMSCI for, you know, for April 9th, if you can participate. And we hopefully, again, either as a club, which Flark is doing it, just parenthetically, or as individuals, okay, would be great. So, you know, just in closing, you know, just a little bit about our publications. Okay, if you're looking for scientific papers, you know, just, you know, you're recording the deck, so you've got it here, okay, in terms of background. But also, I mean, certainly if you follow things like QST, CQ, National Contest Journal, you know, all the ARL publications on the air, QEX, I mean, those types of things. Spectrum Monitor has covered it from a shortwave standpoint. You know, but we've received a lot of publicity, you know, from the ham radio side, in terms of, you know, sort of getting better understanding of why we need you to participate. A lot of those stories are coming up again prior to the April event. So look for them, you know, in terms of updates, in terms of what we've learned in terms of observations going forward. Yeah, and then just lastly, just, you know, in terms of acknowledgements, okay, is that we have a number of partners that we work with: National Science Foundation, NASA, ARDC, also with ARL. RAC, okay, is also a partner with us, particularly going forward here in April. But also Reverse Beacon Network, Weak Signal Propagation, Whisper, PSK Reporter, QRZ, Hamcall have all been great partners in terms of getting the word out and providing the equipment and space in terms of digital space, you know, in terms of getting this done. And obviously the use of the free open space software projects just has been a really good piece of support for us, you know, as a small volunteer group in terms of getting things off the ground. So with that, I guess if I can answer any questions, I'll be glad to do that. And I'm not necessarily the physicist, so if I can't answer the technical question, I will take it down and I will have Nathaniel, you know, or one of the other physicists on board to get back to you. So let me turn it over to you guys. You know, any questions that you have out there.
Question, WS2N?
Sure, WS2N, go ahead.
Yeah, this event looks like the weather will not affect anything. This sounds very good.
Yeah, no, you know, in terms of Earth weather, that type of thing. No, I don't think we're expecting anything. You know, and obviously this is not necessarily thunderstorm season as well. Maybe like in the Southwest, but, you know, be minimal in terms of looking at the effects of sunrise and things like that. But that was a question that comes up, and, you know, in a sense, it can be factored in. Okay, if there's anything that looks like a serious anomaly. So, good question.
Very good.
Yeah, we have some questions from the floor.
Sure.
Michelle, you want to ask this question? Okay, this is Michelle Moore.
Good evening. Thank you very much for your very excellent and exciting presentation. I am Michelle Moore, Kilo Delta 2, Zulu Michael Victor, and I have two questions.
Sure.
The first is, for those of us who have directional antennas, should we be prepared to use those directional antennas? And where would would you prefer us to aim? Or would you prefer just direct antennas line strung between trees and pick up whatever we can? Are we listening to changes coming in, or are we actually transmitting ourselves?
Yes, that's a good question. Okay, and again here, if you're participating in the monitoring event, okay, you know, sort of the AMSWL event, is that basically it's where you are, but you need to document how you're pointing the antenna, the type of antenna that you're using, okay, as well as your equipment. Okay, so and if you go to the page that talks about the medium wave contest, they've got all that information there. Okay, that you know that you need to fill out just to help us understand what you're using and how you're using it. But from a standpoint of a directional antenna, I would suspect point it west from Long Island. Okay, you know, because obviously the eclipse is going to be west to northwest of you and then northeast. Okay, but obviously, you know, just make sure that you do report where you are. Okay, and the equipment. And your second question was?
Well, also, I know people are going up to Watertown, so they're gonna be right in the middle of it. And so, that they have the same question. Okay, do I take directional antennas with me? And if so, where do we aim? But that's all covered in the documentation.
Yeah, that'd be a comment in the documentation for the AMPs. Yeah, and if you'd like, if you'd like, send me a note, wx2r@arl.net. Okay, and I will pass on your question to Nick Hall Patch rather, VE7DXR, and he can get back to you specifically. Okay, because he'll look at your equipment and give you some good advice on it. Okay.
Wonderful. Thank you very much. Now, on the great device, we looked at that, and at the first design involved some very tiny surface mount components. And it was fairly inexpensive to put the initial part together. I think it was less than $35.
Yeah.
But then there was some sort of signal generator that was required that was several $100s. Have they progressed at all as far as perhaps making some of those components larger, so it's a little bit easier for more folks to put together, and or perhaps doing something like?
That's a really good question. I think the answer is yes.
But you know, it'd be good. Those are really tiny little components, and surface mount on that, I think, requires some special equipment, correct?
I'm not sure of. Okay, but in terms of looking at looking at cost to equipment, is that it's a yes and no. I think you know, I don't think we're going to make it's not going to change much between looking at April and last October, but certainly going forward after that, you know, in terms of looking at some of the other experiments, just in terms of looking at the time signal, time delay of arrival, where the equipment is also used, the answer is yes. So.
Aha, and that was something that you just mentioned going forward. There is a use for the grape after the eclipse.
Yep.
And
because obviously measurements of time signal stations and looking at the effects, what we're learning is that, you know, the better we can understand during an eclipse, the more it helps us understand the ionosphere post eclipse. And one of the discussions that we've been having is sort of how do we go forward post eclipse in terms of some of the work that HAMSCI needs to do. So.
Great. I think that needs more attention, what we can do with it afterwards. George, thank you.
Yeah.
Yes,
thank you. Great questions.
So it's not especially expensive, but it's always good to leverage something that we've already invested in. And when I said pre-assembled, I just meant pre-assembly of the surface mount equipment and leave the rest of it up to us to put in box and do the external operations. For those of us who don't have the eyesight we used to have.
Yeah, true. I'll vouch for that.
Right. Yes. Thanks.
Hey, Ken, WB2KWC. You mentioned that the SEQP is supported by N1MN. Do we configure it just like another state QSO party? Or
yeah, I know there's the piece too, because I'm not an M1MM user. I use the N3FJP. I think there's a piece in there for the Eclipse. I know they were going to build that in for the SEQP. If it doesn't look that way, again, drop me a note, wx2r@arl.net, and I'll get you an answer for it. Okay.
Okay, thank you.
But yeah, I know we got a lot of logs, so I would assume that it worked. Okay.
Fantastic. Thank you. Are there any more questions from the floor?
Great group.
Everyone is sitting here in stone silence.
Remember to sign up for April 9th. That's what I can ask you to do. So
We're starstruck or moonstruck, or probably some combination of both. And good job. We really appreciate it.
Yeah.
So kudos to from line to you.
George, question? George?
Yeah, from the group online.
Okay. Ed, can you hear me?
yeah, Lou, I
Go
can.
ahead, go ahead.
Okay. I was wondering if there's any connection with the Super Sid project.
That's one for Nathaniel, not for me. Okay, I don't know of any specific connection, but there could be. Okay, and obviously in terms of things that they're working on. So if you'd like, I'll ask him. Okay, that type of thing. So because I'll talk to him tomorrow because I'll see him tomorrow. So
Okay, I asked him about it a little bit on Saturday. So I
I'll
know
follow.
that there's some interest.
I'll
For
follow on that specific.
people who don't know the Super Sid project, it's a very low frequency monitoring project. Typically down about 24 kilohertz,
Yeah.
and that's an interesting piece by itself.
Yeah, and I know you saw Nathaniel's presentation, which looked a lot different than this one. Because he goes a lot more into the terms of the physics because he's really comfortable with doing it. So, but if you need a copy of that deck, okay, I can get it for you. So maybe George, if you want to coordinate that with me, if you need it, I can get that back to you. Okay. So
Great, yeah.
Okay.
I think the thing to do is to post a link to it on our website. That way, all our members could get to it as they need it.
yeah.
Nathaniel already shared his deck with me.
Okay, perfect. Okay, so it's out there. So if you want to move it around, that's great. I've got no problem with that. Yeah, I mean we're really transparent in terms of things that we're doing. So because we really just want to build the interest in it. So
Sounds true.
Question, Ed, it
Sure,
was a
Gary.
fantastic presentation. You mentioned QST. Was there something already published, or was
no,
it?
there's something coming up. Okay, we've got something in fact, I dropped a note to Becky Schoenfeld today because we're sort of coordinating things. I mean, QEX, the story is out. National Contest Journal, I think it's in the can, ready to go. There's the old publisher in me, right? QST, it's going to go right before the eclipse. So it'll be an April issue, but it'll come out in March. CQ, we've got a story now. Obviously, there's a lot going on regarding CQ, but I talked to Rich Moseson, who says that there will be another issue going forward. So we've got it in there. The Spectrum Monitor story will be far more specific to the medium wave portion of the event, as it should be. Okay, and that story will be running, I think, in the February issue. We're just trying to time it. So we've got a lot of lead time, ahead of April. And then, in fact, I'm working with Radio Amateurs of Canada and Alan Griffin up there, is that we're going to have a sort of call to action, much like this presentation is, for their March-April edition. And then we're going to do a sort of a summary edition because the Canadian scientists have a slightly different aspect than, I guess, in terms of looking at what our funding is. I shouldn't be off the topic on this. In terms of looking at what our funding is. So we're going to do something a little bit later on downstream towards the end of the year regarding some of the findings that are specific to what they're doing up there. So, and there's a lot of other pieces that we're looking to get things in as well, too. So
Great,
yeah.
thanks.
Yeah, my job is to spread it around. Scientific American, I mentioned to you, for the October event, we were really thrilled. CNN covered us in a number of markets. BBC World picked us up as well. I think IEEE picked us up, okay, in terms of some specifics. So, I mean, so we've gotten a lot of publicity that's out there for a lot of different audiences and a lot of different reasons. So all for free, as they say. So.
Question, if you don't mind. What about the maker world? Have you
Yeah,
gotten into
there's a lot of interest in terms of makers, okay, and that's one of the pieces that we're sort of doing. Obviously, we're sort of focused in terms of what we think are some of the traditional audiences, particularly in listing hams, okay, sort of my reason for being here tonight. But part of our post-eclipse work is really with a lot of maker groups, okay, not only in terms of, sort of building equipment, but also understanding a lot of the technology and getting a lot of people involved through the space science portion of it. you know, in terms of looking at amateur radio. So that's a piece that's right on target. Again, you know, we're more specifically focused here on SEQP, get currently licensed hams on the air to help us in terms of gathering data. But, you know, that downstream portion is really there. So you're right on target. Sign you up. Okay. So drop me a note. Okay. We can use you. Okay. That type of thing. So I know you guys do a lot of work with kids, right? So
Yeah, we do have some STEM places.
yeah, as all clubs do. So anyway, any other questions?
Heard. And again, thank you so much.
You guys were just great.
appreciate
I can talk fast with a New York accent and everybody understands me. So,
that.
which a lot of groups, they say, slow down, you're talking too fast. So, but anyway, thanks guys. 73s and stay warm up there. All right. 73s from Palm Beach. So
Thank you.
thank you.
Thank you, George.
Thank you.
All right, so let's start drawings. Stephen, what we have in 50-50.